In this video, we are going to learn about solving quadratic equations. They should look familiar. The only difference is that these problems have an equal zero at the end, whereas before we were being asked to just factor the polynomial. But factoring the polynomial is actually the first step to solving a quadratic equation. We also could solve quadratic equations with something called the quadratic formula, but in this lesson, we're going to focus on solving by factoring specifically, because that's something we've been working on for a while. So I can see that this is a trinomial where the leading coefficient is not 1. So I'm going to start my factoring by multiplying the 2 and the 3 to get 6. Then I'm going to list all the factors of that number. Now this one is a little difficult because technically this one will give me 5 if I subtract, and this one will give me 5 if I add. So I want to look at my problem and kind of confirm, okay, my last term is negative, so I really want something that's going to subtract to give me 5. So what I'm going to do here is rewrite the trinomial so that it has 4 terms, so that I continue to factor by grouping. So I'm going to go 2x squared. I'm going to have a positive 6x and a minus 1x, because I do want it to be a positive 5 at the end. I'm just going to bring down the equal 0 because we're not going to do anything with that until the end. Now that I have it rewritten as 4 terms, I am going to split it down the middle and begin factoring by the GCF 3 times. On the left side, I have a 2x in common, and when I divide out the 2x, I'm left with x plus 3. On the right side, I have a negative 1 that I want to take out because I do want my parentheses to also work out to be x plus 3. Now that I did the GCF 2 times, I'm going to do it one more time by comparing the common factor on each side. And then my last answer is the part of the factors that are left. So normally when we were factoring, we would be finished right here. But since we are actually solving quadratic equations by factoring, the last step is to actually write out 2 equations with my factors, both of them being set equal to 0. It's pretty straightforward from here. The only thing I can do to solve for x on the first one is subtract by 3, so my answer is negative 3. And for the second one, there would be 2 steps. I would add 1, and then the last step would be to divide by 2. So I have x equals negative 3, and I have x equals 1/2. There would be one additional step, which would be to plug it back into the original to check to make sure you get a true statement, but I'm not going to do that here in this video. Okay, we have a couple more quadratics that we're going to solve. You can see the first one is where it's a trinomial where the leading coefficient is 1. And the second one is a trinomial where the leading coefficient is 6. So we will use slightly different steps to factor each one. The first one, I can concentrate on the 12 right away and list all the factors of 12. I have 1 and 12, 2 and 6, and 3 and 4. Since my last term is a minus, I am going to pick something that subtracts to give me 4. So I can see that the 2 and the 6 will subtract to give me the 4. And since it is a trinomial where the leading coefficient is 1, I can go straight to writing my answer. The only factors of x squared is x and x. I'm going to have my 6 and my 2. And since the middle term is negative, I am going to make my largest number negative as well. But the 2 will be positive. Again, since I'm solving and not just factoring, I do have to take that last step, which is to take each of your factors and set them equal to 0, and then go ahead and solve. So I get x equals 6 and x equals negative 2, because you have to move those terms to the other side to get x by itself. Okay, in this one, since there is a number in the front, I am going to go ahead and multiply those. I also get 12, so it's actually the same list of factors that I used above. But this time, since the last term is a positive, I want something that's going to add to give me the 7. So this time I'm going to actually use the 3 and the 4. And again, since this is a trinomial where the leading coefficient is not 1, I am going to rewrite this with 4 terms so that I can continue from here. I actually am going to make them both negative because I want the middle term to be a negative 7. So you do have to pay attention to your signs. From here, I'm going to split it down the middle. On the left side, I have the GCF of 3x. So I'm left with 2x minus 1. And on the right side, I'm going to actually take out a negative 2. And I will also be left with 2x minus 1. I know I'm on the right track because my factors match right here. So I'm going to have 2x minus 1, 3x minus 2 equals 0. And then again, we got to just go ahead and set them both equal to 0. So I have 2x minus 1 equals 0. Which ends up giving me x is 1/2. That's one answer. And then the other one is 3x minus 2 equals 0, which ends up giving me a positive 2/3. So it is okay for your answer to be a fraction. It is what it is. As long as your math is good, it doesn't matter. We have a few more examples we're going to look at. This next one here looks a little different. As you can see, it's actually already factored out. So this is more about you recognizing that there's nothing to do here except to actually solve. So notice everybody gets set equal to 0, even the x that was probably a GCF in the beginning. That means this answer has 3 answers, okay? This one's already done because x is by itself. I have to add 6 to get x by itself here and subtract by 4 to get x by itself here. In the next one, again, being in the habit of always looking for the GCF first, I can see they both have an x here. So I'm left with x minus 6. From here, you can't factor anything else. There's nothing else. So I can solve, though, because these are solving, not just factoring. So my final answer will be x is 0 and x is equal to positive 6.